Hi, in today's video we will study type-based classifier. Now let us start with Bayes theorem. Bayes theorem for posterior probability states that conditional probability into prior divided by evidence. That is, probability of hypothesis given an evidence is probability of evidence given hypothesis into probability of hypothesis divided by probability of evidence. Now these evidences are set of rows given in a data set having n numbers of attribute. So basically evidence is nothing but set of rows with n attribute values, and each row is composed of different values in this attribute. So attributes are from A1 up to AN. So first row will contain values from small a1 to small an. That's why we represent evidence E as a row or a tuple which is enclosed in angular bracket with set of values n. So and probability of evidence is nothing but probability of all these values occurring in a table out of total number of rows. And we calculate joint probability. So instead of writing E, we are substituting set of row values or attribute values. So in the same Bayes theorem, we represent probability of H given some set of values of attribute is equal to probability of some set of values of attribute in a hypothesis given a hypothesis P of into P of hypothesis divided by probability of these many events or values occurring in a table simultaneously. And we know that probability of value 1, value 2 up to value n is nothing but a joint probability of all attribute. And joint probability of all attribute is always 1. So with this formula, let us understand or let us solve one example. Let us consider one example. This data set is predicting outcome of a match, predicting variable value whether match is going to get win or lost based on past data of say playing teams. Now this team data is calculated based upon 4 attributes. These attributes are weather condition, last 2 matches, humidity and toss. As you can see, weather condition, last 3 matches, whether team has won last 3 matches or not, what is the humidity today, and whether they have won a toss in a particular match or not, and the prediction is whether they are going to win this match or not. So prediction is binary. So this is an example of binary classification. Weather condition can be either it can be rainy, it can be overcast, or it can be sunny. So there are only 3 possible values. Somewhere they have won only 1 match, they have won 2 matches, or they have won 3 matches in the past. Humidity level can be only of 2 types. Humidity can be high or it can be normal. Now question is that we are given one concept that if weather condition is rainy and if team has won 2 matches, so I would write it over here. If weather condition is rainy, they have won 2 matches in past. Currently humidity is normal and they have won toss in current match. What is the probability or is it possible by this team to win this match or not? So I want answer yes or no over here. So I will calculate supporting hypothesis either for yes and for no. Whatever is the maximum will be our binary classification output. So in order to calculate this value, first we construct something called as frequency table. Now there are in total 4 inputs. That's why we will create 4 different frequency tables. First table will be of weather condition. Second table will be of last 3 matches win. Third table will be of humidity and fourth table will be of win loss. Now in each of this attribute we can have only two possible output, whether final one match is yes or it is no, or it is not one. So yes and no is calculated for each of these tables. Next statement, we will calculate how many yes attribute or how many yes predictions, yes value for output variable is there in our table. There are only 9 yes entries, no entries are only 5. So at the end, in each table, we have total yes entries are 9 and no entries are 5 in each of these tables. This is constant. Okay. Rest of the value will be observed and filled accordingly. Now in order to fill this particular row, let us consider sunny weather condition. So I will highlight all those rows which contains sunny value. This one, not this one. Okay, so how many sunny rows are there, or how many rows are there where value sunny is there? So in total there are 5 values. So one thing you must note that summation of yes and no in this particular sunny row must be of type total to 5. Now out of this 5 rows, how many yes values are there, or how many rows are there for which output value is yes. So as you can see, the bold done spaces are nothing but yes values. So 3 values are yes and 2 values are no. So we will fill up the values of this table accordingly. Later on, I will highlight or I will find out number of rows which contains value overcast. Now for an overcast, there are only 4 values and all of these are of yes. So in overcast row for yes, we will have value 4 and 0 in no column. Likewise for rainy, I will highlight all the rows which contains value rainy for weather condition, and I will find out how many yes and how many no values rows supporting it. So there are only 2 rows with yes and 3 rows with no. So as you can see, if you take out the total of this column, this would be 9 and this column would be 5. This has to be done. If it is not summing up to same value, then there are some errors in your calculation of observation of these values. Now let us move to another column, that is win last 3 matches. Now we have 3 possible values. Either they have won for only 1 match, they won 2 match or 3 match. So one thing we can do is highlight all one match is just, we can either follow the process that we have followed, that I can find out all the rows which are containing one win, one win, one win, and find out how many yes and no's are there. Another thing is that I can highlight only yes and no part. So yes rows are highlighted, and out of these yes, calculate how many ones are there. Okay, so there are only 3 ones, so I will write 3. How many 2 wins are there? So only 1, sorry, 2, 3, 4. So this would be 4. And how many 3 wins are there? 1 and 2. So that will be 2. As you can see, this sums up to 9. Okay, so 1 wins are bold, and out of no, there is only 1 win. Okay, and likewise table is constructed. You can follow either of this approach to construct this frequency table. Once this frequency table is done, we no longer require our original observation data. Second, we will calculate probability of how many matches are won in past and how many matches are not won in past. That is given as probability of won matches, that is 9 out of 14. As you can see, in each of this, won matches are always 9. And total number of matches are nothing but sum of 9 and 5, which is equal to 14. So not probability of not winning a match is nothing but 5 out of 14. So we have this data in our hand. Now we will find out condition that is given. So in a question, given condition is that weather is rainy. The condition given is that weather is rainy. They have won past 2 matches. Currently humidity is normal, and currently they have won toss. Now we have to find out what is probability with all these 4 possible values. The possible four values are given in question. So what is probability of winning given that these values are current? So probability of winning given that rainy, two wins, normal and toss win is given. And we will also find probability of not winning given all four possible same values. Let us start with calculation if first. Probability of winning given possible four values A1, A2, A3 and A4. These values are specified over here. So this can be given as our naive based classifier as probability of A1, A2, A3, A4 given that we have won this match into probability of winning. So as you know, this joint probability can be later on written as probability of A is given winning, probability of A2 given winning, probability of 3 given win and into probability of 4 given win into probability of win. Now A1 with win is nothing but rainy with win, two wins with win, normal with win and toss is won with win into probability of winning. Now what is probability of rainy given that we have won this match? So probability of raining given that we have won this match is 2 out of 9. Probability of 2 wins given that we have won this match is 4 out of 9. Probability of humidity normal given we have won this match is 6 by 9 and probability we have won this toss and won this match is 3 by 9 and probability of winning is 9 by 14 already we have calculated. We will substitute these values and calculate the result. This result is 8 by 567. We will keep it aside. Now we will repeat the same process for not winning a match. So probability of not winning a match with all these four possible values is with the help of May-Waves classifier probability of A1, A2, A3, A4 given that we have not won the match into probability of not winning the match. Likewise, I have to separate it out all these values. Probability of A1 given not winning match, probability of A2 not winning the match, probability of 3 not winning the match and probability of A4 given not winning the match into probability of not winning. So A1 is nothing but rainy. So probability of rainy not winning the match. So from table we will calculate this value as probability of rainy with not winning match is 3 out of 5. 2 wins and not winning matches 2 out of 5. Normal and not winning matches 1 out of 5. And win toss but not won the match is 3 out of 5. So these values are substituted and probability of not winning is 5 by 14 that we have already calculated. We will do the math and find out the answer. The answer turns out to be 9 by 875. So we have now two different values. Probability of winning given that all four conditions happen and probability of not winning given all four conditions happens. So we have 8 and 567, 8 by 567, 9 by 875. Let us normalize it. So normalizing is nothing but our given value divided by sum of these values. So for winning, given value is 8 by 567, 567 divided by sum of these probability, which is turns out to be 57.84%. And for not winning, given value is 9 by 875 divided by sum of these probabilities, which is turns out to be 42.16%. Now from these two, as you can see, the highest percentage is 57.84%. That means if four conditions happens, it is more probable that the team is going to win in a given match. So this is how basically naive based classifier works. Let us discuss where this naive based classifiers are applicable. So there are main four broad categorization or four broad application where this classifier is applicable. First one is at text classification, where we have to classify a document which is according to its title into a particular category. So we use this algorithm to check with all permutations and combinations of probability to classify this particular document according to its title into a particular correct category. Say for this example, C programming is a title, then it should be classified into a computer engineering books and IT engineering books. Likewise, we can use this algorithm for language detection. That means whatever the written text is there, whether that text belongs to Hindi or it is that text belongs to Gujarati or whether it belongs to English like language. So that kind of applications are solved using naive-Bayes classifier. Likewise, in a business domain, we have something called as sentiment detection, which are used by traders and retailers to identify the feedback, whether it is positive feedback to our company product or a negative feedback based upon the text they have written. So basically, customers write long reviews, and from that reviews whatever the words are occurred, according to the occurrences of the word we are detecting whether it is a positive review or a negative review. So Naive-Bayes solves these kind of classification problems also. Another category of classification problems which are solved using Naive-Bayes is spam filtering. As you know, nowadays even all email providers have this inbuilt functionality which identifies some of your mail spam. They directly move those mail into spam folder and based upon some mechanism, and that mechanism is nothing but your name based classifier. So we can also use other supporting classifiers which are explicit to our email system, and those email filters are DSpam, Spam Assassin, SMARM Base, ASSP. All these use naive-based technique. Third category of applications are hybrid recommender system. These recommender system works along with naive Bayes in popular sites like Alibaba, Flipkart and Target. They do not only use recommender system but they use naive Bayes along with recommender system so that whatever suggestions made by their system is having better performance and more accuracy than the standalone recommender system. And the final one is online sentimental analysis. We also, these sentimental analysis is also known as opinion mining. What is the tone of that text defines the actual outcome, whether that sentence is positive or negative. So sarcasm is already there, but when we write it in a textual language, this sarcasm removes. So we want system to learn, remove or to identify those sarcasms and classify the given sentences correctly. Say for example, in a sentence, if there is a brilliant word occurring, then by default it is said that if it is brilliant, the review or the message is classified as positive example. But whenever brilliant is used in a sarcastic way, then it must be categorized correctly into negative type of review or negative type of sentences or example. Say for example, when I say my flight has been delayed, brilliant, and that brilliant is in a sarcastic way, it is not a good brilliant. Okay, so system must be powerful enough to categorize this brilliant as negative category of negative type of sentiment. So there here most of the system uses three type of sentiments. It can be nice or it can be positive, neutral or nasty or negative. So we can use either a single word or a pair of words to classify a given text or a document into a positive, neutral or negative way using naive-Bayes classifier of course. Now, as you have seen that naive-Bayes classifier only uses frequency table for its calculation, and this frequency can be only calculated if it is discrete in nature. Values in a table are discrete and they are of type categorical. So what will happen if attributes are of not type categorical or they are not of type discrete? That means they contains real values. So we first must discretize or make conversion from continuous type or from real type to category type. And this process can be done with the help of binning method. Remember, we have discussed this binning method in our unit number 4, where we transfer or we convert continuous valued attribute into a discrete valued attribute. Example, say for example, we have a particular problem that in a bank there are some customers who are visiting, and we want to market our new credit card to those customers. Now these customers are rushing in a bank at different frequencies or different times. Say for example, the highest rush is at from PM 11 a.m. to say 2 p.m. So during that time we have to target most of the customers because maximum people are visiting back in those hours. So whatever the working hour or visiting hours of a customer is there in a bank, so if this plot is continuous, then say for example at 9 p.m. bank opens, and say for example it closes at 4 p.m. Okay, so this is from 9 a.m. to 4 p.m. and we have plotted that customers are coming at this kind of frequencies. These are nothing but number of customers. Okay, so this is a continuous graph. There are number of customers that are visiting in a particular time window is not discretized. So these values are real. So what do? We perform something called as binning. Now this binning is nothing but dividing your time into different windows and calculating number of occurrences in that particular time. So from time 9 to say for example from time 9 to we will calculate say for example 11 a.m. How many customers are there? So now we will have discrete values. Say for example only 50 customers are visiting. From 11 to 1 a.m. how many customers are visiting? So on. So this is the process called as handling discretization or something called as binning. And this binning is used for naive Bayes classifier when it tries to work with real values. So that is all for today. In today's video, we have seen naive-Bayes classifier with the help of an example. We have also seen its application and how to handle continuous value. Thank you everyone for watching this video. This is Munira Topia signing out.